Dear students, this is the fourth session of your course IT Systems and Logistics, and today we will treat the value of information. So the agenda of this video is that we shortly review the content of session 3, or the key elements of that, and then we will talk about the topic of today, which is the value of information. So we have seen in the last session that with supply chain mapping we can enhance the transparency of a supply chain and its processes. So it gives us a visual representation of, for instance, the goods that flow within a supply chain, the information that goes along with the flow of goods, the overall processes that define the flow of goods and information, and also the financial flows that occur throughout our supply chain, both upstream and downstream the supply chain. So from the retailer that we have also seen in the online game, upstream until the manufacturer and the suppliers of the raw materials. So just shortly recapturing what we mean by a supply chain map. Here you see an example of one. That starts as the customer and then goes down until the supplier. And just as a visual aid, I will draw this to you. So we start here at the customer and then we go along the supply chain upstream until the supplier. Here we deal with just, as this example shows, we deal just with one core company that includes some certain products, and we see depicted the customer and the supplier on this side, and this is all our company. Sorry for my writing. The supply chain map gives us a visualization about the processes that occur in the company and also related to the supply chain partners, and it gives us also key performance indicators of the processes within the company. So when we capture the as-is situation, the current situation, then with such a supply chain map we can re-engineer the processes, and it shows us also the bottlenecks and the inefficiencies of the flows, so we can re-engineer it and make it optimal in the current situation. So supply chain mapping helps companies not just to identify the inefficiencies that I just mentioned before, but also to improve the strategic relationships with the customers as well as with the suppliers of this certain supply chain partner. It also helps to visualize the processes of the company, and this helps also in increasing the communication quality as well as the understanding for each other's processes within the company functions. So another thing that it does, it helps to analyze and develop the core competencies of a company. So when you think about a supply chain strategy, when a company redefines its core competencies, then it focuses on what it is good in doing and outsources more of the functions that it's not so well in doing, or where others are just better in doing. So that is what we intend with the focus of core competencies. So now we are talking about the value of information, and I give you a short introduction to it. So with the value of information, we think about the value that an information gives to a certain person or an entity, and the value it implies. When an information comes with a value, it also comes with a cost that we need to balance one against each other in order to appreciate the value of the information. So the implication is of the availability on the effective design And the management of an integrated supply chain goes along with that. So as we have seen also in the supply chain game, or in the Mountain Dew game, that is also called the beer game, that the value of information that travels along the supply chain could help to redesign the structure of the supply chain. As we have seen, we had the retailer, the wholesaler, the distributor, and the manufacturer, and there were great oscillations within the demand of each supply chain partner. So if we could eliminate unnecessary links of the supply chain, then we could redesign the supply chain and integrate it in a certain manner. And when we cannot eliminate those links, then at least what we can do with passing valuable information is that we can install information technology in order to help us support to get the information to the right person at the right place at the right time. So this leads to the potential availability that increases, and when more information can be passed throughout the supply chain. But of course, this comes also to a drawback, because more and more information does not mean that it's better and better, because we have the value of information that decreases with certain factors. That can be more and more information that is, or data that is unfiltered or not analyzed and analyzed enough, that can lead to a trade-off of more and more data coming available. So we need to pay attention if we talk about information, or if we talk about data that needs to be still transformed into information. Throughout the last sessions, we have learned which types of information are important. For instance, within the game, we have seen that the inventory levels are quite important in a supply chain, because if we do not have enough inventory, then orders of our customers that might peak or be unexpectedly high could lead to back orders, which is also called negative inventory, because it implies that we cannot satisfy the demand with our inventory levels, and so if the customer is willing to wait, then we would create some back order and deliver the demanded items at a later stage. What we have also seen in the supply chain game is that orders are very important. Orders are those information, or this information that arrives at our suppliers and also ourselves as being part of a supply chain. So this is the order size also that you had to decide it upon within the game. That gives a very important information. And also from the point of view of the manufacturer who produces the products that then will be sold throughout the supply chain, the production state information is also very important. And last but not least, also the delivery state of the items that are being shipped or are in way to be shipped. So information, when it is available, can help reduce the variability in the supply chain. So for instance, if the retailer would pass the information about the end customer demand to the factory, then the factory would be able to make a better forecast about or a better plan about what to produce in which time period, so that it can better serve the customers throughout the supply chain. And also we have seen that promotions or discounts lead to peaks or in case of promotion, it leads to peaks of the demand because it uses a kind of lower price throughout the supply chain at certain stages, and that might lead to a higher order quantity, and this distorts the overall picture of the demand within the supply chain. So if we could pass the information throughout the supply chain about the real end customer demand, then it would be easier either to do a forecast or to know the real demand. And also passing the information of the end customer demand throughout the whole supply chain would enable a better coordination of, and I mentioned it already, the manufacturer or the producer throughout the distribution system, and also the marketing strategies, for instance, of the retailer. So marketing strategies entail that some kind of strategies like discount events or promotion events to induce some artificial demand at the end customer. So if we pass information that would also enable the retailer to better serve the customer by ordering tools for locating the desired items, meaning that if we install some kind of tracking tracing system throughout and upstream the supply chain, then the retailer would have a better idea when the items would actually arrive at their premises, so that they could pass this information to the end customer, and this one would know then when certain items would arrive. So the tracking and tracing systems throughout the supply chain can even help the retailer to get better information for the end customer, which would be overall better than for the overall supply chain. So it would enable the retailer to react and adapt also the supply chain or to problems that could occur along the supply chain in a more rapid fashion, talking to the collaborators within the supply chain and then passing the information to the end customer. And this overall could also help to reduce lead times that are not technically enabled, which means that, well, if a truck from A to city A to B would need, if occurring for the overall traffic regulations, and if that would need at least 1 hour, for instance, that would be a technically induced lead time. And of course, this could not be changed. But lead times also include waiting times throughout the supply chain. So if this should be waiting, sorry for my handwriting once again, but lead times also contain waiting times. And if the information about waiting times would also be passed, or if we could enhance the supply chain by passing information about the real demands throughout the supply chain, then each of the partner could plan and schedule their processes accordingly, and that would reduce the overall waiting time throughout the supply chain, not including, of course, the technical related lead time. So if you remember the bullwhip effect that we talked about in previous sessions, we had the customer demand, which at the retailers did not vary that much, but upstream the supply chain, inventory and back orders really fluctuated to a high or to a significant extent. And just a short repetition about the factors that contributed to the variability of the demand. We have also factors that could enhance the variability. due to certain factors, which would be demand forecasting and the technique that lies behind it, and also to the inventory levels that we have seen. So for instance, one method that is applied often throughout the supply chain is a technique that is called periodic review policy, and that means that for a certain point in times the inventory in a warehouse is checked and then evaluated. So not continuously we know how much is drawn out of the warehouse to satisfy the customer demand, but we just look and make an inventory from time to time. There is one single parameter that belongs to this periodic review policy, that is the base stock level. And the base stock level is defined as the average demand during the lead time and within the review period, plus a multiple of the standard deviation of the demand during that lead time and the review period. And that is what we call then the safety stock. So in crude words, you need to assume that we have an inventory level that is depicted here on the y-axis, and on the x-axis we have the time periods, and we have the information about the inventory just at certain stages of time. And then the base stock level is something that we define, which is the average demand. Let's assume that it's here. During the lead time of the review period, let's assume that the review period is here, so the demand would decrease the inventory stocks at certain stages, and in order to not go below that certain level, we induce some safety stock that we define here that enhances then the average demand during the lead time, so that it would not hit a level that is below zero and what we would define then as a backlog. So the average of the estimation of the average demand and the demand variability is done using the standard forecasting smoothing techniques. So if you look at quantitative analysis of the demand variations, then you will see that there are a lot of methods available to forecast the demand, using also some kind of smoothing technique. So estimates then based on this method get modified as more data along the time period that goes on becomes available. So we have a continuously adaptation of the demand forecasts in order to be able for a production or a manufacturer to change the plan accordingly in time in order to satisfy the demand. So the safety stock and the base stock level depend on these estimates of the average demand during the lead time, and the order quantities are then changed according to induced variability of the demand. And this is what we have also seen and done in the online game. So if you looked at the video where I played the overall game and did the simulation, I varied or I changed my demand, my order quantities according to the level and or the regarded level of the order quantities that came in from my customer, just as a rule of thumb, without applying some smoothing or standard forecasting method, but just as a rule of thumb. Other factors that contribute to the variability of demand, as we have seen, also is the lead time. So with an increase in the variability, the variability will be increased by an increasing lead time. That means the longer the delays become between our order and the time that our order arrives from the supplier at our premises, the more uncertainty is induced, because the time periods, they just, or the weeks, as we have seen in the game, just continue to come, and orders from our customers arrive in a continuous manner, but our supplies will not arrive at the certain pace. So this induces a lot of uncertainty in our order sizes. So the safety stock that we've built and the base stock levels as well contain a component that regards the lead time in their estimations, but of course it still regards, or it still has some uncertainty that goes along with it. So the longer the lead times, we can memorize as a rule of thumb. A smaller change in the estimates of the demand variability will imply a significant change in the safety stock level and also in the base stock level. And that applies once again that we can have significant changes in the order quantities, and that once again alongside the supply chain will tend to increase the demand variability along the supply chain. Another important factor that we have not regarded too much until now, but I mentioned it so far, is batch ordering. So for instance, all supply chain partners, but especially also the retailer, use batch ordering. So he aggregates the overall demand of the end customer to batches, because then the retailer and every other partner as well of the supply chain would spare some transportation costs, because you can imagine the more often I or another company orders items, the more transportation costs you will occur every time. So you want to somehow aggregate the orders in order to pay just once the transportation times. That means if the retailer does so, that means for the wholesaler, which is linked to the retailer, that he observes larger orders, but also followed by several periods where no orders or just small orders may occur. So we have quite a variability of the demand when it comes to the retailer. And this distorts the pattern of the demand as well within the orders. And this is exactly the bullwhip effect that we have seen. So such patterns result from transportation discounts, as I have mentioned. So the less often you order a transport, the less often you need to pay for it for large orders. So you want to aggregate the demands. And also, that is another pattern, the periodic sales quotas and incentives. So some kind of marketing events as discounts where the prices are low distort the order patterns as well and lead to this variability, which is really bad for a supply chain. Linked to this are the price fluctuations that are induced via promotions or discounts mentioned here. So this is the other side of the picture, that we have prices that go up or down, and depending on the price, also the stocks will go up and down. And this means that if supply chain partners use these kind of promotions, then they use some kind of forward buying, because they think that if they buy more than they need, then they will have for certain the demand in order to sell these items that are more than the end customers has already required from them in a certain time period. So he also thinks that larger orders will occur during the discounts, and small periods at other times where the price is not as small as in discount times. And this leads overall to other factors that contribute to the variability. So everything is kind of part of the same picture, but is somehow interrelated. So due to the price discounts, we have inflated orders. So the supply chain partners induce themselves a distorted picture of the demand that makes it difficult for every other partner in the supply chain to get the right picture of the real end customer demand. So we have inflated orders during shortage periods. This is another part, not just the discounts, but also when we see that we have peaks in demand from our customer, then we are more prone to order more because we want to hedge against shortage periods. We want to maintain a certain service level, and this means that we want to increase a little bit of our buffer in order to avoid shortages. So we can have the effect then when a retailer and a distributor suspects that a product will be short in supply, then they would anticipate receiving a supply proportionally to the amount ordered, meaning that, as we have seen in the game as well, if we experience a peak in demand of our end customer, then we are more prone to react to this and ordering a little bit more in the future in order to have enough buffer. And after the period of shortage, then the retailer, for instance, would go back to the standard orders that we have seen also so far, and I demonstrated this as well when I played the game, so that when we see that our inventory builds up, then we would order a little bit less in order not to increase the inventory costs. So all these kind of distortions and variations in the demand then influence the estimates also for the forecast of demands throughout the supply chain. So how can we avoid now this whole game of distortions of the real demand to take place? And one idea would be to centralize the information of the real demand. So we would make centralized, we mean that we would make the demand of the end customer available to each of the player within the supply chain, which is meant, or which is stated here. And this then, for all supply chain partners, would induce that they can make more accurate forecasts and use that for their planning, especially for the factory. That would be beneficial. And this would also reduce the overall uncertainty because the supply chain partners would have transparency of the demand, and that would reduce then the variability because they would know what happens. Another thing is that, the supply chain partners should get rid of the component to distort demand via discounts. So an everyday low pricing strategy, or a stable, which is more key, a stable pricing strategy should apply so that these distortions would not be induced by prices or discounts, which is kind of the same. Another method or other factors that could be used for methods to cope with the bullwhip effect, we have also mentioned beforehand, is the lead time reduction. So if we have non-technical lead time induced by, for instance, waiting time due to plans that use some demand information that is not accurate, could help to reduce the overall effect of the bullwhip effect. So we have two components of the lead time that needs to be mentioned here. One is that we have transportation or order lead times, and they could be reduced, for instance, by concepts like cross-docking, and that is a specific transportation method where you change over from one transportation mode to another, and that one is planned more in detail so that no waiting time is induced. So, for instance, you could imagine that products coming from China via maritime logistics and ships, could that be planned to go then by truck to their end customer? So if cross-docking is applied, then these two transportation modes would be linked together in an efficient way, looking at the schedules and then planning accordingly so that no waiting time would accrue. And then we have another component of the lead time, which is the information that needs to be passed together with the physical items. And we have systems available today that can do the tracking and tracing of the items themselves, but also who are able to pass the information in real time. And these are called electronic data interchange, which are systems that can read the information about the premises of an item, pass it to a system that gives a code so that the information about the location of the items can be passed from one system to the system of another company. So they can electronically exchange the data of the transportation of the items. So this is very technically. Other methods that could be used are less technical, but build more on trust and on collaboration and relationship that are strategic partnerships. So if two partners of the supply chain, like we have seen also in the supply chain mapping, change the way the information is shared with each other, then this can be beneficial and also reduce the bullwhip effect. One method that is mentioned here is the so-called vendor managed inventory, and this is a concept that is used at a manufacturing company, for instance, together with a main supplier, where the main supplier is responsible of the inventory levels at the manufacturer, so they have some kind of service level agreements, so that the supplier fills the inventory levels according to their information in an autonomous way, so that the manufacturer does not need to induce some purchase orders at the supplier, but this is done in an automatic way. And this also helps to reduce not only the lead time, but also is used to reduce the waiting time that is included somehow in the lead time. And this is mentioned here. So the manufacturer does not need to rely on orders placed and needs to do it by themselves, but this is done by the retailer or more generally by the supplier. So now the good question is if it would be so easy to share the information in a centralized way. Now we need to focus on how the information sharing can be actually done. Because, if you look at the game and the supply chain, then we see that the retailer had a quite easy time. So the oscillations about the demand and the variability was not that high as, for instance, for the manufacturer. So the retailer would benefit less from centralized information sharing than the manufacturer. So the problem is to know or to incentivize and motivate the retailer to actually share the information with all supply chain partners. So the information sharing is a problem of many industries that can lead to inflated forecasts, as we have seen, and the bullwhip effect. So the problems that we have seen already that distort the demand are well known. So the question is what we can do now to prevent this from happening. And as we have seen with the strategic collaboration or partnerships, what we can also do is a little bit more on the contractual side of the collaboration. So we could use some capacity reservation contracts where the buyer pays to reserve a certain level of capacity or of items at the supplier. So the supplier would manufacture some items, and the buyer would reserve a certain level of that capacity. In that way, the supplier would be certain that a certain portion of their manufactured items would be taken already, and that induces some certainty for the supplier. So as an incentive, a range of prices for different capacity reservations in time could be provided by the supplier to induce this kind of motivation to already place an order, so that the supplier would be certain that this kind of, or this portion of items are actually already sold. And this also gives a signal to the supplier that the buyer has a true forecast about his demand. I'm sorry, that the customer of the supplier would have. So this is kind of signaling system. If the customer reserves a certain portion of the to be manufactured items, then the supplier has some kind of certainty that this specific capacity level will also be met. Then we can have some kind of advanced purchase contract where the supplier charges a special price before he builds the capacity to manufacture the items, so that he can be certain that his investment will pay off because the capacity will be needed. So when the demand is realized, then the price that is charged would be different, but at least he would be certain that the items would be sold. So once again, the buyer would commit to pay a certain price for the items, so that he would reveal the true forecast also of the buyer, because otherwise he would not make a contract with a special price then to be charged. So we talked already a lot about effective forecasting. So sharing the centralized information about the true demand throughout the supply chain is one way to go. So the retailer, of course, also needs to find out the real demand of their customers. So they need to do a forecast, and this is typically based on a kind of analysis of the previous sales that he experienced, and then he would also take into account certain pricing or promotion events that he wants to induce, and maybe also some release of new products if that is the case. So all this information would be then included in the forecast of the retailer. The distributor and the manufacturer now would make their own forecast, and this would be then influenced by the factors that are under the retail control. So also here we see that centralized information would be key to ease this kind of forecasting method. Also being informed about the retailer's promotions and pricing events would be something that they could take into account. And also the mentioned new products of the retailer. So it would make things much more easier for distributor and manufacturer if they would have more information about the intentions of the retailer. This would be very frequential, as we have seen. So a good idea would be, in order to share all this information, to set up a kind of a cooperative forecasting system where the retailer would share his information about the end customer demand, and there could be some high sophisticated iterative forecasting methods implied or implemented in this kind of system, where all the participants could collaborate somehow, giving their information about their forecast, and then agree upon a collaborative forecast instead of each of the partners making his own. And this could be a good tool to share the information in a centralized way throughout the supply chain. That sounds very good in a sense of sharing information, but of course it comes with challenges. Because now we need to think about how to set up such a system and how to share the information and how to give access to these kind of systems. Because we have seen that some suppliers and also manufacturers may pertain to different supply chains that might compete with each other. So the good question is where to install such a system and who should have the access to it and who should administer such a system. So one thing could be that we need many interconnected systems where we would share the information, or and this would also, well, if we have many of such systems, that would induce the problem that they are not coordinated. So which system would contain the truth, and which one would rather have an information that is not so true. So if they are not coordinated, then this results in the problem that we have local optima. So the good question is now, who will be responsible for such a centralized system? So who will also optimize then the schedule and the forecast? Another question is who would benefit from the centralized information? So how will the savings or the increase of efficiency, how would that be shared among the supply chain partners? How should the splitting take place, etc.? And who should have also the costs of running such a system? So there are many questions that are attached to such a centralized system that are very difficult to respond. So some methods to address the issues are, as we have seen, people can make contracts with their suppliers, or that can engage in strategic partnerships, as we have seen also with the supply chain mapping. Yeah, but there are, of course, trade-offs. So as we have seen, partners have conflicting objectives, and the design of a supply chain comes also with conflicting goals. So practice is not as easy as it seems. Another factor that we need to consider is that we have a decreasing marginal value of information. So obtaining the right information and sharing it is not free. It comes to a cost. If you imagine that we need to set up an IT system for sharing in a centralized way information throughout the supply chain, then this system would need a server somehow, or a cloud system where the information would be stored. There needs to be some experts who analyze the data that comes in, and to provide some methods for forecasting or decision support. So this all comes to a certain cost, also in terms of hardware, not just software, but also people who can run the systems. And when it comes to the information that should be shared, then also there it's quite complex. So there are a lot of different programs, like loyalty programs that companies use to to monitor the demand of the customers, but also tracking and tracing systems like RFID, where RFID, if you have not heard of that, means that is an abbreviation that stands for radio, frequency identification, so ID, and is a technology that that can track and trace items. We will deal with that at a later stage throughout the course in more details. So there's a cost of exchanging information when it comes to systems, and then we need to weight the benefits accordingly. So also, if we look at the degree of information or data that we need to collect in order to arrive to valuable information, needs to be monitored, exchanged, analyzed, and shared accordingly. And the more information that we collect, or the more data that we collect, that does not necessarily lead to a higher value of information. So at a certain stage, we have a decreasing marginal value of additional information, meaning that we have already reached a very high level of data that leads to a very high level of value. And if we collect more and more data, then the value decreases. So, the exchange of detailed information is costly, and the more frequent we do it, does not necessarily lead to more value. So it's not a linear system, let's say. So we need highly to understand the costs and the benefits of particular pieces of information that we want to collect. We need to decide if we want to set up such a collaborative system also on the frequency of collecting this information, how much of this information or the related data needs to be stored, and how much of it needs to be shared throughout the supply chain, and specifically also in which form or format it needs to be shared. So information systems are very useful to support the user of analyzing, collecting, and developing information of the data. So there's a true advantage of advanced information systems, and the role of information technology is very high in this area. But if you look at all the developments that come along the label with big data and big data analytics, then there is a challenge of collecting and analyzing unlimited data volumes. It comes with a very high cost, and you always need, as we said beforehand, to weigh the benefits against the costs. So we have an impact of the internet and e-commerce that go along with shops, where customer information and behavior can be analyzed and used as information then for forecasting as well. Good, and here we are at the end of the lecture of session 4. I hope you have a lot of questions. The next lecture will be about information management and the role of IT systems in details. If you have questions, please put them in our forum, and then I will try to answer them. Not at the moment, as I need to solve some IT issues with my access to Moodle, but please put them there anyways, or write me an email. So thanks a lot for watching, and thanks.